Hello, we are Team 28 from the Electrical and Computer Engineering class of 2021. Today, Daniel Maruzic, Ellie Geramonti, Noah Greco, and myself, Nathan Clemmings, will be introducing and demonstrating our capstone project, the Budbot, a revolutionized growth chamber. Our design is a 6x2x2 enclosed unit that offers individuals the capability to autonomously simulate environmental conditions to stimulate various types of plant growth. To achieve this, we covered the interior with mylar, a reflective electrical and thermal insulator, and implemented an AVLUM 5050 SMD LED plant strip grow light that can be configured to run by the hour. We also included a DHT11 temperature humidity sensor in correspondence with two 12-volt computer fans which activate or shut off when temperatures reach a specified threshold. Lastly, a 12-volt submersible pump that pumps the desired volume of water at midnight every night was also implemented. All of this is connected through wiring to a Raspberry Pi that we coded to carry out the above stated functions.
Here on the right side of the screen, we have a simplified version of the circuit being used on our prototype. This is for an easier demonstration of the application for this video. Taking a closer look at the board, we have an extension board for the Raspberry Pi, which is then connected to the GPIO port on the Raspberry Pi. The first LED here represents the lighting circuit on the greenhouse. The second light is for the fan circuit, and then the third light is for the pump system for the watering. On the actual greenhouse prototype, rather than being connected to the LEDs, these are connected to a 12-volt relay which controls the state of the circuits mentioned previously. Next, in place of the temperature sensor is a potentiometer that acts as a switch used for demonstrating the fan circuit. Here is the app portion of our capstone. As you can see in the home screen where information is displayed such as temperature, humidity, fan, and light status. The temperature and humidity are measured from the DHT11 sensor in the prototype, and the information is then communicated back to the application where it is displayed on the home screen for users to check. Next, the system can be configured using the Configure page on the application. This page allows you to save and load customized configurations based on the plant of choice of the user. We have pre-saved some settings for common garden plants such as potatoes, strawberries, tomato, basil, etc. However, there is still an option with the application to create new customized profiles. By pressing the watering and temperature button, you can adjust the amount of water the system will receive each week as well as the desired temperature of the system. By pressing the lighting button, you can adjust the hours of operation for the lighting. This was designed to select off-peak hours of electricity to save money while growing plants.
So our application works by first initializing the server, which the user can then connect to through the website. After the server is initialized, the pin configuration is initialized from the configuration file here. Then the program enters the main program loop. So in the main program loop, the first thing that happens is the system status is checked to determine whether it should be turned off or on. If it's turned on, it will continue, otherwise it will keep looping here. So if the system was turned on, the config is loaded from the file, and the temperature and humidity values are read from the GPIO pins. And using these two values, the light status and the fan status are determined. The system then checks if it requires watering. If the system requires watering, then the duration the pump should be enabled for is calculated using the surface area of the pot the plant is planted in, as well as the amount of water specified by the user. And then the pump is turned on for that required amount of time. Finally, the parameters are updated of the system. So the light status, fan status, temperature, and humidity values are updated and stored into a file, which can then later be sent to the user on the website.